Hi everyone, my name's Jim Webber, I'm Chief Scientist at Neo4j, and today I'd like to chat a little bit about the emergence of graph technology across the data industry. And in particular, I'm super enthusiastic that graphs have just become so important over the last 18 months that everyone is trying to do them. One of the approaches we've seen out there in the marketplace for trying to do graphs is where we take an existing database, a column store in particular, which is excellent for kind of hash map style, column storage retrieval, and we try to graft, if you'll excuse the pun, a graph API on top of that. So we have an engine which is native for columns under the covers, and we have a graph-like API atop the piece. And end users interact with the database as if it were a graph. They come in through the API, they have maybe a graph query language that they can use, and under the covers this is mapped onto the native data model in some way. And in one sense, I'm really pleased about this because it means that people outside of Neo4j, outside of the kind of core graphista movement, are becoming increasingly convinced that graphs are an important part of our data future. On the other hand, I'm slightly nervous about the engineering from mapping from a graph model to a non-native graph model, down to a column model or what have you. I think this provides food for thought for those of us that are thinking about working with graphs. Under the covers, if I'm native for columns, I don't have the ability in my DBMS to support the kind of integrity checks that graphs require. How do I ensure that a relationship that goes between two nodes properly exists? How do I ensure that there are no dangling relationships in that model? Because natively, I don't really understand relationships. I'm just creating them and reifying them by convention in my columnar model. Up the stack, although we may have a graph API, mostly we don't have Cypher. Cypher being by far the dominant graph query language out there now. Neo4j supported Cypher for a long time under the auspices of OpenCypher. A bunch of other technologies are supporting Cypher, including Apache Spark. On the kind of non-native side of things, we have other languages, second generation languages compared to Cypher's third generation declarative language and so on. So the engineers that are using this, the end users that are using this technology aren't being given perhaps quite the best affordances that they could get if they were using native tech. Back under the covers, those databases that are designed for extremely high scale, eventual consistency and so on, which are actually very respectable databases and good for their native model, tend to lack the kind of strong consistency semantics that we need to keep graphs in good health. We need strong consistency semantics in graphs to make sure that we don't have pointers that end up dangling. So we have to keep a consistency of two in a graph. In a system that lacks transactions, in a system that lacks acidity, even modern low-cost acidity, as we could do, we end up under normal operations being in situations where mixed read-write workloads can put the graph into a highly inconsistent state, where from one point of view a relationship appears to exist, from another point of view a relationship appears not to exist. And being in this superposition of states leads to non-deterministic behavior in the graph, which then leads that logical corruption to spread around the graph and ruin or detract from the value of the connected structure you've worked so hard to build. So not enforcing graph integrity, it's not the fault of the underlying DBMS. The underlying DBMS is solid and competent for its native data model, but now we've tried to twist it to support some other data model, we're finding that it's creaking. More holistically, we find that the newer entrants to the graph arena don't have much in the way of history with graphs. Hopefully they have a great future with graphs. Hopefully graphs have a great future generally. But at Neo4j, we've been worrying about graphs for almost 2 decades, and we've worried about nothing other than graphs for those 2 decades. Conversely, the new entrants maybe have months or perhaps years worth of worrying about graphs, and it's quite a sophisticated arena to be in, quite a sophisticated domain to be in, and it's a domain where I think longevity counts. If you've got an underlying column store and you've got a rigid schema from that column store, it's part of the contract of working with it. It means when you want to mutate your graph, when you want to change your graph layout, as we often do, we take that for granted relatively in graph world, you have to do a bunch of quite onerous ops work and migration work in order to make that happen. In Neo4j, we tend to have a light touch approach to that. We have constraints rather than schema, so graph evolution is constant and actually relatively pleasant. In terms of the affordances that we give developers, Neo4j has the Cypher query language, as I mentioned, which is a beautiful, live, evolving declarative query language. Other systems that take third-party OSS languages end up with second-generation imperative languages, literally a DSL on top of what we consider to be Neo4j's core traversal API. Neo4j provides very strong consistency semantics. We, in fact, provide causal consistency even across multi-data center scenarios. In the absence of such strong consistency, you're going to get corruptions at runtime, almost without doubt. Now, I think the engineers that are building this non-native graph stuff on top of the native column stores, for example, are not at all without merit. I think they're probably, as many database engineers are, some of the finest engineering minds in the industry. And looking at what's been done in the industry, we see some very good efforts to be able to denormalize the data model within the mapping code between the Graph API and the underlying non-native store. I think that's really important because it means for certain operations, as long as you stay within the limits of the denormalization, you might get reasonable performance. However, the moment you step outside of the bounds of that denormalization, you fall off a cliff edge in terms of performance. So perhaps if you can stay within depth 3, a friend of friend of friend, that might make a bunch of sense. But actually what we observe in reality is that graph operations tend to be far more sophisticated and rich than that. For example, even if we're considering a simple data center scenario, from app to container to host to NIC to backplane to switch to router, I'm already way beyond depth 3 before we've even got into the complexities of the rest of the data center. And it's the same if you think about healthcare records and clinical pathways. It's the same if you think about NASA planning a mission to Mars. The depths of these graphs is certainly, for any interesting kind of data information you want to find, any knowledge that you want to reify, you want to be able to go to arbitrary depth efficiently. If you've got a cliff edge after depth 3, that's going to sell you short. You're going to get super excited about graphs and then find that the graph isn't delivering for you. Down at the storage level, if I've got to do things that are mechanically expensive, hash lookups over the network and so on, and try and reify a graph out of that, then it's going to be slow, particularly compared to Neo4j's order 1 graph traversal semantics. So ultimately, why I'm very pleased that everyone and their grandma are now becoming very interested in graphs, I think as users, as people developing systems, people developing applications, we have to be aware that we're not performing an apples-to-apples comparison. Neo4j is built from the ground up for graph workloads, and it excels at graph workloads. Other systems are built from the ground up for other workloads, and they excel at those workloads. But simply dropping a graph API on top of it and declaring victory actually is a little bit disingenuous. So if you're going to pick up graph technology, you're going to build graph-based systems, do kick the tires of all of these systems. Give yourself a chance to explore where they're strong, where they're weaker, and make the right graph-based system work for you. It's been great hanging out with this video camera and my lovely camera operator back there. Love to see you guys in the community soon. Bye bye for now.